All right, this is 6.1, and we're solving radical equations, and some of these are easier than others. This first one's not too bad. If you think about it, we're always trying to get the variable by itself, and this time it has a square on it. We don't want to try to square root anything until we get that y squared by itself. It just makes a mess if we do. So what we're going to do first is think about PEMDAS backwards. There's nothing. Oh goodness, I've just been talking away and didn't record anything. Okay, if you start up at the top, we have 4 minus 16x squared is equal to 0. I want to get the x squared by itself so I could square root both sides. By the way, if you thought of this, you could actually factor this with a difference of two squares if you wanted to solve it that way. But we're going to solve it by taking square roots since that's what this section's trying to teach. But anyway, to get the x squared by itself, I could subtract this 4 from both sides like you see me having done here. And I would get negative 4 is equal to negative 16x squared. And then if I'm trying to get the x squared by itself, the next thing I would do is divide both sides by this negative 16 that you see that I did. And then those negative 16s would cancel out, and we would have x squared equal, well, a negative over negative is a positive, and 4 over 16 reduces to a fourth. So now I have x squared is equal to a fourth. Well, I want to get the x by itself, and it's squared. What's the opposite of squaring something? Square rooting. Now, when I square root, and it's an even root, I need to remember there's a positive root and a negative root. The square root of x squared would just be x, but I'm going to have two different things that I could square to get a fourth. Remember, when you've got a fraction under a radical, you could put the top under its own radical and the denominator under its own radical. And you would end up getting the square root of 1 is 1 and the square root of 4 is 2. You have two answers, plus or minus a half here. Okay. On 25, we have 81 minus 9x squared is equal to 0. And again, this would actually factor as a difference of two squares if I wanted to solve it by factoring, because when we have squares, we have lots of different ways to solve them. But what we're in this section going to do is try to solve by square rooting. And the reason I know I can do this is there's an x squared term and there's a constant term, the 81, but there is no term that has just an x in it. That's how I know I can actually use this method of solving in this case. So that's what I'm going to do just to demonstrate that technique of solving. Let's move the 9x squared over to the other side, because since I just need one term on each side, this actually would make everything positive on both sides. And I would have 81 equal 9x squared. Now I know that I've got an x squared here and I still want to get it by itself, so I'm going to divide both sides now by 9 to get that. Remember, we're always trying to get the variable by itself, aren't we? Okay, that would cancel out and leave me 1x squared, and 81 divided by 9 is 9. Now I've got x squared is 9. How do you solve a square? You square root. The opposite of squaring is square rooting. So I'm going to square root both sides, but the minute I square root, I have to remember it's an even root, so we put a plus and a minus on it. If it had been a fourth root, we would have done the same thing. Anytime you got an even root, you have two answers, the positive one and the negative one. All right, square root of x squared is just x, and then I have plus or minus, the square root of 9 is 3. So if you're writing your answers, you could do plus or minus 3. These problems are going pretty quickly so far, aren't they? Most of them are short and sweet. All right, now number 27 looks a little bit different, but it's not too much different. You have x plus 5 squared under the radical is equal to x plus 5. And they say find the values of the variable in each equation. For what values of the variable is each equation true? Well, you know that if you square root something, you get it back, don't you? And that's what this looks like it's saying. But here's the thing. I can't plug anything I want to in there because I cannot have a negative under the radical, can I? So what numbers, in other words, could I plug into there? Well, it would be, I would need that x plus 5 to be greater than or equal to 0 in order for this to be true. So if I solve that little inequality, because it can be 0 or it can be positive, it just can't be negative, can it? It would be x has got to be greater than or equal to negative 5, and then it would be true. So that's actually our answer. So a lot of what we're doing here is saying when is this true, and it would not be true if I put a negative number in there. Let's try one just to show you what I'm saying. What if I put negative 3 in there? The square root of negative 3 plus 5 squared would be the square root. Negative 3 plus 5 would be 2 squared. That'd be the square root of 4, which is 2, right? Well, let's do the right-hand side. If I plugged in negative 3 plus 5, I would get 2. But the thing about it is over here when I square rooted the 4, I should have had a plus or minus 2. I need it to be just 2. And so I can't just plug this in here without having the x be greater than or equal to, oh, I picked 1. Okay, ignore that. That's kind of like, that's not working out the way I thought it would. Let me try another one. I need something less than negative 5. Let's try negative 6. I meant to show you an example that didn't work, and I showed you one that did work. Let's say negative 6. Negative 6 plus 5 squared. Well, that's the square root of negative 1 squared, which is square root of negative 1 squared would be square root of 1, which would just be 1. But let's plug it in over the other side. Negative 6 plus 5 on the other side would be negative 1. And so 1 does not equal negative 1. Now, why did I say this was just 1 right here? When I write the square root, when I'm solving a problem and I write the square root, I have to put a plus or minus on it. But if they've already got the square root on it like they do right here, I'm just supposed to assume that they just want the positive one. If they wanted the negative one, they would have put a negative out front like this. And since they didn't, I'm supposed to just give positive 1 as an answer. But over here, I get negative 1. Over here, I got a positive 1. If I had square rooted myself, I could have put a plus or minus on it and everything would have been okay. But when they write that radical sign, that means you can only look at the positive root. So positive 1 does not equal to negative 1. That's why we can only plug in numbers greater than or equal to 5. I think that was always a little confusing to me. So if I write the root myself, I did the square rooting, then it's plus or minus. But if they have a root on it already, we only want the positive root. Let's look at 29. We have the cube root of n plus 1 cubed equal to n plus 1. A lot of what this is testing is, do you know about roots and what happens with them? Now, I can put any number in here that I want to and it'll work, because when I take the cube root of a number, there's only one number cubed that that gets you a number. It's not like a square root where I could say, well, what's the square root of 4? It's 2 or it's negative 2. If I want to say what's the cube root, for example, of negative 8, there's only one thing that would give me a negative 8. Negative 2 times negative 2 times negative 2. If I had the cube root of a positive 8, there's only one thing that would give me 8 cubed, and that's a positive 2 times a positive 2 times a positive 2. So since there's only one root, this is always true for all real numbers. Mostly, this is a thing that has to do with definitions. For odd roots, there's only one answer. For even roots, you got a positive answer and a negative answer, and so that's what messes stuff up. Sorry for that long pause. For number 33, you got the square root of x plus 1. I didn't realize I had left the iPad running. It says, for what value does x represent a real number? Or for what values of x does each expression represent a real number? All right. When I'm square rooting, I cannot square root a negative number. If I do, that's an imaginary number, and we're going to talk about that in another chapter, but so far, you're not even supposed to know they exist. And besides, if we're talking about real numbers, we would say, well, if I want to square root something, whatever's underneath there has to be 0 or bigger. So we would write that this way. I can square root 0 and get 0. I can square root 1 and get 1. But I can't square root negative 1 and get a real number, because there's not two of the same thing that would multiply together to give me a negative 1 that are real numbers. So what I do is, anytime I see something like this, I take what's under the radical and I say it's greater than or equal to 0. And then I just solve for x. Subtract 1 from both sides. If x is greater than or equal to negative 1, then I would have real solutions. And that's really all you have to do there. We do this exact thing a lot when we're talking about what would the domain of a function be. For example, if I had this let me just make a different example. What if I had y equals square root of x plus 2, and they want to know what's the domain of that? They're asking me basically for what values of x am I going to get real numbers out of that. And what you do to determine that is you take what's under that radical and you say, well, it can be 0 or bigger, and I'll have a real number. And so the domain has to be, that stuff under there has to be greater than or equal to 0. The expression has to be greater than or equal to 0. So if we solve it on out, we say, oh, my domain is all real numbers as long as x is greater than or equal to -2. And so we use that actually a lot, and that's why they're giving you this number 33 here.